Hi there everybody, welcome to our vodcast on how to make a line graph. Now, during certain labs, you'll probably be given data and you'll be asked to graph them in usually one of two ways, a bar graph or a line graph. So during a line graph, what you'll have is you'll be given a data set here and you'll be asked to plot them on the graph. So when you do that, you're going to plot your points and then connect the points with a line, whether it's a dotted or solid line, depending on your directions, you'll be connected in with a line, hence the name line graph. So let's get started on how this works. So here's our example for tonight. We have our graph paper here in the middle, and we have our data table here on the left. All right, our data table tells us plant height versus time, so how tall a plant grows over a period of time. On the left, we have our time intervals going from day 0 to day 40, and then we have our plant height goes from 0 centimeters to 65 centimeters. Now, this is fake data that I made up, so if it seems outlandish, I made it up for a reason. Let's take a look at the first thing that we have to do. The first thing that we need to do on the graph is we have to set up our y-axis. Our y-axis is this left side of the graph itself. It's the part of the graph that goes from the top to the bottom of the page. So this is our y. And what we need to do is make sure that we can figure out how to number these lines here going all the way to the top so we can either finish at 65 centimeters or above it. And the reason why we pick 65 centimeters is because it's our highest data point. So we have to make sure that we set it up so we include 65. If you set up your y-axis and it only reaches like 32, you've done something wrong because there's no way you can plot 65 there. So there's a special little formula that we can use. All right, so when you go to set up your y-axis intervals, or the numbers that each line is worth, divide your highest data value by how many lines you're going to use. Then to make your life easier, round to the next whole number. So it's basically encapsulated by this formula here. Highest data value divided by the amount of lines you're going to use. So how many lines make up the y-axis, and then that leads to your interval. So let's figure that out. All right, so as we said, our highest data point is 65 centimeters, and I counted out already, and we have 34 lines going up to the top. So when you do the math, you take 65, your highest data value, divided by the amount of lines that you have, you're going to come out to an answer of 1.9. Now, you're not going to want to go from 0 to 1.9 to 3.8 to 5.7 because working with decimals like that is going to be annoying and it's going to be easy to make a mistake. You want your intervals to be consistent all throughout. So that's why we say round to the next nearest whole number. So the nearest whole number to 1.9 would be 2. And when we say nearest whole number, we mean the nearest highest whole number. You never can round down because, for example, I can't use 1 because 1.9 is the minimum that I have to use in order to get to the top to include 65. So I always go up to the next highest whole number, which is 2. And that's what we did here. If you take a look, the y-axis is now set up in intervals of 2. Every line is worth 2 centimeters. And it takes us all the way up to 70 at the top. Now, as a result, what will happen here is even though I've gone past 65, that's okay because now I've ensured that I can plot 65 on my graph. So it all works out really nice for me. In addition to that, make sure that when you number your y-axis, your numbers line up with the lines right next to the line so we know that the lines are that value. So for example, if I put 2 next to the line, I know that when I hit this line here, it's going to be worth 2 centimeters. If I put the 2 in the middle of the box somewhere on the side, then I don't know where inside the box it's going to be the value, or 2 centimeters. So make sure you line up your numbers perfectly with the lines going up the y-axis. Once we do that, we kind of have to figure out how to set up our x-axis. Now, we did the centimeters here on the y, and now we have to do the time on the x. The x is the one that goes across here. Now, it's a little easy because we started off at day 0, so day 0 is at this point here. Afterwards, we have 29 other lines to go by, and we have 4 data sets to go by. So we're going to kind of do the opposite. Instead of taking our highest data point, dividing it by the number of lines like we did for the y, for the x, we're going to take the number of lines and divide it by how many data points we have to plot. Since 0 is already taken, we're just going to figure out where we have to put these 4. So I have about 29 lines going across. I have 4 data sets to divide that by, and that's going to come out to about 7 1/4 or so. but that's not going to work if we go by that. So in this case, we round down to the nearest whole number. So we're going to go about every 7 lines. And when we do that, you'll see that our data points are spaced out nicely. So that's how you set up your x-axis and your y-axis for graphing. That's the trickiest part. Everything else is kind of simple. The next thing we have to do is we have to title our axes. So we have to label them and tell the reader what they are. So for example, in this example here, time is labeled at the bottom, so we know that these numbers mean time. And then temperature is over here on the y, so we know that these numbers mean temperature. Typically, time will always go on the bottom because that'll be your independent variable. And then your dependent variable is going to go on the left here, what depends on the time, as we talked about in the scientific method. So when we take a look, we see that day 10, day 20, day 30, day 40, and 0 days over here represent time. So that's what we're going to label the axis, time. And we normally put the unit that we measure in, so here we have days. On the y-axis here, we have plant height. So each value here means a certain centimeters of plant height, like 12 is 12 centimeters of height, 14 is 14 centimeters of height. So all we're going to do is we're going to write the title for that. Plant height is represented here on the y, and we include again the units in parentheses, centimeters. Once we title the axes, we can then move on to the next step, which is titling your graph. Now it says x-axis title versus y-axis title here. You could flip them both ways, it doesn't matter. But what you need to do is the title has to tell the reader what this graph is about. So it's real simple. I'm going to take my plant height title here, and I'm going to verse it against time. And when I do that, I'm going to write it as this. Plant height versus time. And there's my graph title. Simple, clear, and it gets to the point and explains exactly what my graph is showing. And it's easy to write. We now have to plot our data. So when you plot your data, be sure to plot your data point where the x-axis value and the y-axis value intersects. So when we do that, here's our data table here. At day 0, we have 0 centimeters. So 0 centimeters is here, and on day 0 there. So we have an X there. Day 10 has 6 centimeters. So we go to day 10, and we find where it intersects 6 centimeters, which is over here. So we put an X right there. Day 20, we go to 15. So we go up, and we notice that 15 is in between 16 and 14 here. So we plot our X there. And we do the same thing all throughout for the rest of our data. So 32 is this line right here. And then we have 65 on this line right there. So we have our data points plotted. And now the fun part, connect the dots. Who doesn't love connecting the dots? So all you're going to do is take your pencil and take a straight edge if you have one. And then you're just going to connect the dots. We're going to go from this point to that point to that point, this point to that point, and that point to that point. You always go from point to point, from left to right. You don't skip all the way across here and then come back. You go to each point as you move across to the right-hand side. Now sometimes, depending on the graph and the data, you can use what's called a best fit line or a best fit curve, which will go through all the data points and it represents the average. But mainly what we'll do is we'll connect specific data points like this. And that's how you get your line graph. Hopefully that was easy enough, and I hope you found that helpful. Thank you very much for your time.